find them as cool as the DC3s, huh? I find them phenomenal. Okay? Big honking radial engines out there, throwing oil everywhere. So fun. So fun. Okay? So they're going to rivet. I'll show you a brief video here. Riveting. Riveting. Name the components. What components do you see here? We have a rivet gun. Okay. Our bucking bar. Anvil. Anvil's a cool name, but that's not the right. Bucking bar. Anvil kind of gives me that whole forage, you know, covered in black soot, you know, fun attitude there. Riveting's a lot cleaner than that, so unfortunately. Anyway, so he's got his gun, he's got his piece of aluminum, and he is bucking that rivet through it. These are called clecos, even though the videos will later on will say clecos. We try to resist that stupidity and call it clecos, okay? Clecos. Clecos are what hold the aluminum to the form or to the ribs. Clecos, okay? They're super fun. They hold the aluminum in place while you buck the rivet. You try to get the right size hammer for the right size head. Does that make sense? Okay, so if we're shooting a round head, you want to make sure that rivet fits inside of it. Otherwise, it makes a smiley face. Okay, we don't want smiley faces. We want smooth, round head rivets. When you're bucking the rivet, make sure you have your pressure regulated correctly. Okay, too big of a gun, it'll send it to China. Okay, too small of a gun, and you will buck it all day. Okay, and then you want to keep solid, consistent pressure on it. It's a rivet. You're hammering it in, and what happens is it makes a shop head on the other side. Okay, so I'll play it back real quick. It's only a minute long.
Plugging holes. Yep, coming through the drill. Need a longer drill. I hope it's legal that these rivets.
Probably. I can't say everyone, but you'll see an aircraft do a gear up landing. Okay. At that point, you know for the next 60 days, you and rivets are becoming well acquainted. Okay. Because what happens is they do a gear up, all of the skin on the bellies and possibly on the bottom of the cowling, all has to be removed. And it's not like a car that you just try to rip everything off. You try to literally go through and drill every single rivet out so that you will have a template for the new aluminum that you're going to put on. If you damage that, then all of your holes are going to be off. So you're literally going through trying to remove a damaged skin wherever it got peeled back so that you can replace it with skin that you have a good template to follow. Okay? At some point in your life, you're going to do that. I think I started when I was 12. We had an Apache, or maybe it was an Aztec. I think it was an Aztec. Do a gear up landing. That was my first one. And I just remember for the next, 20 days drilling out rivets on a belly. Okay. All right, so, yes? Well, you can just hold it on there. His goal is probably to keep a consistent head so he's not pushing it So he's not pushing it off to a side. So that's probably, he's just trying to keep it consistent. Do you have to move it? No. If you've got a good force on the back of it, fine. But he wants a smooth shop head. He wants it to look nice. That's probably why he's moving it. All right, rivet identification. How do we know what rivet it is? Okay, and just like bolts, there's a glorious table in your AC 4313 to give you an idea of how beautiful how beautiful those bolts are. Did you lose your AC 4313?
I don't know if I lost it. I put it in the air switch.
All right, hey, if you have your AC 4313 and it's not really yours, give it back to Geese, please.
Yeah, I'm gonna have my name.
All right. Rivet layout and spacing requirements, okay? So, there is actually a spacing requirement for each rivet that you put in. Whoa, 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 okay? Rivet install, rivet removal, okay? Aim small, miss small, aim big. You go with a really big rivet, okay? Special rivets, uh-oh. He's walking around aimlessly. Who stole his book? Okay. Did you write your name in the front of it? Okay. Can you kindly look in the front of your book and see if your book is missing? Is it in the back of the room? All right. Hey, it was back there on the table.
Was it actually?
I saw Mr. Kelly get up and walk over there, so I'm assuming it was back there.
It was over by the mailbox.
Okay.
I must have short-term memory loss.
All right. So, and then there are, just like your wonderful bolts, there are also special rivets and special fasteners. Okay? For those instances that you cannot get to the back of it. Wait a second. There are going to be times, for example, inside an elevator, that you cannot get to the back of it to buckle the back of the rivet. So what do? Well, we have something called blind rivets that are not actually blind, but the rivets you can't get to the back of the rivet to make a shop head. The automotive name for blind rivets is called a what? No, it's called a pop rivet. Why do we call it pop rivet? It's because the tool pops. Okay? Wow, and it was probably named by someone in Georgia. Okay. So, an AN or MS-20 code designation, slight difference in our numbering system. They represent the same rivet. Ooh, does this sound vaguely, horrifically familiar? Oh, bolts. We have MS numbers. We have AN numbers. And we're not sure if it's Air Force, Navy, or Army, Navy, are we? Air Force, Navy.
First, so.
Okay, all right. I thought it was Air Force, Navy because there was a goal by naming it Air Force, Navy that they would actually work together. But sorely failed. Okay, all right. Head style is represented by the number attached to the AN or MS-20 designation. So an AN 470 is a type of rivet. Wow. That is a round head style rivet. Or we get to an MS-20. What is the MS-20? It's the same as the AN 470. Oh, wow. And then we get it to a 426 style rivet. The material is designated by letters. Alpha, delta, delta, delta. Alpha, delta, delta, delta. Okay? All right. What do those numbers mean, Ryan? What do those letters mean? Is that what you're going to ask me?
Those the only two.
No. And just for your enjoyment, if you'll open that book right beside you, you can start to see a table in there of rivets. Rivets. Rivets.
4-21.
4 dash what?
Page 4-21.
4-21 in your book or in your? There they are. Okay, 421. All the cute little designations for the head styles, just like those X's and T's and dashes and triangles, and the heads on the rivets, which are teeny tiny, also have a designation for what they are. And if you want to know the part number, Mr. Scroggins, that can also be found in the table in chapter 7. Okay.
7-54 and 55.
Ooh, in your book it's 7-54, 55. All right. So diameters. Diameter for bolts. How are bolts measured diameter-wise? Clayton? The diameter of a bolt is measured in what increments? Sixteenths. And links are in eighths. Well, guess what? Rivets are a whole lot smaller. So we go to a diameter in 30-seconds. And it comes followed by a dash and length in sixteenths. Okay? Good. Rivet heads were standard in 2 head styles after World War II. 2 head styles. Okay? Universal and flush head. Okay? What's another name for flush head? Countersunk. Countersunk. Flat head, countersunk, flusher. Okay? Universal head or round head rivets. Universal round head rivets. The round head are typically stronger. Okay? Because it's holding on the outside of the surface instead of cutting material to put the head into the material itself. So you have more holding the outside surface. But why do we use flush head rivets in aviation? Aerodynamics. Back to physics class. We want a smoother, less turbulent airflow over the airfoil. Or in a pressurized aircraft, we want to hold in the pressurized air better, stronger. Okay? All right. So we have an AN round head, and then we have a countersunk or flush rivet. We have a smaller round head rivet. Now, you got to realize when you're looking at the aircraft, it's really difficult sometimes to say, ooh, is that a dome or is that a universal? You're looking at something teeny tiny. There's times where, for example, on the side of the seats, the tangs, does that bring back a memory when we were doing the tangs? Yeah, Bueller. Okay, those rivets that hold on to the tangs are these round, kind of a dome style. Okay, then we even get to an AN full 42, which is kind of a perfect circle here. Okay, flat head, perfect circle style. Brazier head rivets has a large diameter, makes it a little bit more surface material touching it. Round head, flat head, brazier head. Okay, and AN 470. AN 470, AD being material that it's made from, or made for. Then we get to 4 being diameter for 30 seconds with 4/16 length. Length. We don't break that down. It's always over 16, okay? 4/16 being a quarter, but we don't go to that. It's just 4/16. Is that simple enough? So 4 30 seconds and 4/16. 4-4, yes.
Would the universal or the round be considered stronger? Or is that? Because for the counter sunk there is more material, or less material than the universal. But the round is probably taller, but the universal is probably wider. Or does it matter?
Yeah, so I think to answer your question, the universal head rivet, the round universal head rivet. Are you comparing that to
Dome.
the dome? Yes. So you're touching more surface area.
Okay.
Touching more surface area. Good. All right. And then if you have to use an MS number, the DD material, 5 diameter, 5 what? 30 seconds, oh boy, is it a Friday? Is it Friday? All right, and 6/16. 6/16. So what happens when we get to 15/16? What's the next number? We'd go to a 1, typically. Or you'd get to a 16, would you get to a 16/16? 17/16? 18/16? Man, that's a huge rivet. I can't think of any time that I've used a rivet that's like 1.5 inches long. All right.
We do go to one.
We'll go through the numbering system in just a minute. Yeah, you'll go past the 1, but I can't even think of, I'm trying to rack my brain to think of a time that I would use a rivet that long. All right, so length of rivet. Length of rivet, we already have that kind of idea here where we get the diameter, same thing, okay? Those of you who don't like that, you can use your caliper, veneer caliper, bam, measure it in 30 seconds of an inch, okay? And it does not have threaded portion. Those of you who hate the threaded portion, congratulations, they are smooth. So you don't have any of those to guess with, okay? If you have a smart vernier caliper, you can put it in fractions. And then, voila. And it will always be in reference to 30 seconds. So if you come up to a 1/4 inch diameter rivet, what is that in 30 seconds? 8:30 seconds. Whoa. Whoa. All right.
Do they make 4 inch?
Sure they do.
First base.
That's big. Sure. All right. And then the length of the rivet, just like a bolt, goes from where? The bottom of the head till the end. Come over here, guess what? From the top. So the portion that's actually inside the aluminum. Okay? Gotta give you the British term, make you feel, aluminum. All right, these crazy numbers that you thought you had escaped, you thought wrong. Okay, they're back again. So we have 1100. Guess what that is? Pure aluminum. Does that seem familiar now? Aluminum rivets are soft and easy to drive. Good for fairings, baffling, and plastics. They're not for structural use. Why in the world, Carter, would they not be for a structural use? They're soft. They're soft. Okay? So if we want something that is probably corrosion resistant but strong on the inside, we go with a 2117. Most commonly used rivet, favored for their high strength and shock resistant because it has copper and magnesium in it. Okay? Make sense? All right, then we get to a 5056, which is a magnesium based. Use magnesium parts to prevent dissimilar metal corrosion. Give me a place that we would use 5056 rivets. Sumps? That's fun. That's a fun one. All right. Anyone?
Rubber pedal.
Okay, letter pedals. We'll use a pen on them. Sure.
No, I don't have an example. I'm just.
Ava.
Where two different materials are connected.
Give me a component that we use it on. Like what? Okay, all right. So in 1940s, they did have magnesium flight control ailerons. And rudder vaders. Just sounds cool to say every time. Rudder vader. Rudder vader, those are magnesium. We buck 56 magnesium ailerons and rudder vaders. Get magnesium rivets. Does it make sense now? Oh.
magnesium brittle? How is it gonna not just crumble?
Well, you know, it's not brittle for a little while. Okay.
It's not brittle, it's up to it. That's all that matters.
Yes, sir.
The example on rubber paddles are saying that they're made out of magnesium. Is there 100% magnesium? How do they compare to this?
You know, I don't know if they're 100% magnesium. I don't know if they're 100% magnesium.
Close?
It is an alloy.
So there's something else.
There's something else in it, yes.
Because like with this, it's only
It's like
five
magic flashlight.
Yeah, is the inside something harder than the outside magnesium because that's what's actually touching the component itself? I don't know. It's a good point. Cheddar twist. Yes, Amanda?
So if we're supposed to use magnesium with magnesium parts, how can we use like steel bolts and aluminum? Like I still don't understand why we can use dissimilar metals if there's a dissimilar metal corrosion.
Good, all right. That's why you take corrosion and corrosion prevention class. But you're putting a bolt through an aluminum hole, not because you feel like you should, but because the manufacturer tells you you should. Okay?
But I also don't understand, because isn't steel stronger than aluminum, so how come that bolt doesn't like push the bolt?
Oh, it could. It possibly could.
So it's just because the manufacturer.
Correct, and that's the way it was approved. Yep, you have an aluminum fork landing gear and you're gonna put a steel bolt through it.
Yeah, that's why I'm confused.
You do that because that's what the manufacturer had it certified with. Which one typically is going to corrode faster? The bolt, steel, will typically corrode faster. Aluminum, once it begins the corrosion process, it actually protects itself. Okay?
Because
That's
it
what-
says the oxide.
Yes. Yes. Oxide kind of refers to steel. But yes, okay. But then we use corrosion resistant. Does that sound familiar? Corrosion resistant steel. So it's trying to resist that. And so those two items are supposed to work together. Over time they would corrode together.
What makes the steel corrosion resistant? What is in it?
Anyone remember? Remember? Oh, Shane does.
Nickel.
Nickel. Oh, he nailed it. Perfect.
Riveted.
Perfect. Nickel. Yep, because nickel does not typically corrode easily. Okay. Yeah, okay. All right. Mild steel rivets, no letter. They're used for riveting corrosion-resistant steels in firewalls and exhaust stack brackets. Okay? Mild steel rivets. Mild steel rivets. Okay? Monel. Inconel, Monel rivets. Used for riveting nickel steel. Ooh. What is that all about? What are you thinking that's all about there? Yep, go ahead.
Well, I just wanted to ask, I'm fuzzy on Inconel and Monel. What do those things mean? What are they talking about?
Ooh, Inconel and Monel, it's a type of metal material, just like stainless steel. We're just adding another, material compound to it. Inconel is extremely hard, heat resistant.
Is there another name for Inconel or Monel, like a layman's term? No, this is what it is. Okay.
It is, yep. I can't tell you the compound they make of them, but I'm sure you could ask AI, they'll probably give you a 25% correct answer. All right. A little salty about that. All right. Copper rivets. Ooh, copper rivets. Where in the world would you use a copper rivet and why?
Try.
Hey. That's expensive. That's an expensive rivet. All right. Where would you use a copper rivet? Why? heat and copper, heat and copper, heat and copper. Probably not. We'd probably use a Monel.
Electrical?
Electrical,
Yeah, I don't know how, but something like that.
I don't know how either, but I'm trying to think of one. Copper rivet. If it was subject to needing to be, yeah, Ava?
Would it used to be like broken for some reason?
Yeah, I was trying to think of that, like, if you had one of those old, they had those old little, really cool flip, emergency exits where you'd pull it up and it'd kind of pop out and you could wave at people, you know? They don't do that anymore because of kids, like
Sarcasm.
us. Anyway, so those could be copper riveted, cause you would try to break them loose, yeah.
You break the rivets instead of just having a latch or hinge.
Yes, because kids are kids, no matter where you are. Yes, Jedediah?
Let's say latches, anything that needs to be grounded.
Yep. I was trying to think of maybe a grounding cable originally. Could I ground? That would be really a pain in the butt if you had to remove it.
I think probably more common in older aircraft, with like leather interiors, different latches and things, seats.
Maybe so. All right, we have a new rivet, which is a 750 T73, just because it sounds cool. It's a 1979 stronger alloy that Boeing uses in the 767 wide body. But the 787 got even more promoted, right? Because we went to composite. Zinc is the major alloying element in the 750, okay, 7050. Do you have to have these numbers memorized? Nope. That's why you have AC 4213 in front of you, Mr. Scroggins, right? Right?
I was pulled up, dude.
All right, 2017 T, very hard, and it's susceptible to cracking. Any problems there? Mr. White, would there be any problems there? What would be the problem with using a potential cracking rivet?
I mean, very, very.
That could be a problem, but what else could it be? If it was subject to vibration, for example, on a flight control, one specifically the elevator, and you're flying along, and there's lots of vibration due to the pilot going like this, what could potentially happen to the elevator? You could pop the rivets out, right? Because it's subject to vibration. Have you ever stood behind an aircraft while it was running at like 2,500 RPMs and looked at the flight controls, how much air movement is over the flight controls? Has anyone had the opportunity to do that? Stand within just a foot or two, not that it's a good practice, but stand within a foot or two of maybe the elevator or stabilator and watch the air movement over those? It's insane to watch it go like this. I mean, to watch the aluminum just sitting there, and this plane's gonna get up in the air and fly like that. Okay? Have you ever done that? Yeah. It's insane how much movement there is over those flight controls. And so can you imagine if all of a sudden you get all that movement and it pops the heads, okay? So we want good, tight fit. 2024, also known as an icebox rivet. So when it comes in the mail, now they used to be where we could save them for several months. Now it's usually about 2 weeks. So you're going to do a repair, you order the skin repair, you get it all ready, then you order your rivets. They come in, they are within a cold package. You pull them out, you either use them that day or you put them in the refrigerator until you're ready to use them. They're good for 2 weeks now. 2 weeks, I wonder if even some are up to 30 days. But they will come in with a sticker, and it will say used by this date and a batch number, so that when you use them, you could say use them with this batch number, okay? And that's if there was a problem in the manufacturing process, that they would say, oh, hold on, you use those rivets, we shipped those rivets to you, go ahead and drill them all out, they were bad, okay? And so now they'll come with a batch number.
What happens after the specified time?
You take them and you put them in the gondola, the trash can. Yep, cannot use them. Because they were manufactured, to be used within a certain time period, okay? They've heat treated them and they're shipping them right to you. Yep.
Why are they cold? Why are they kept cold?
Ooh, good question, okay? Somebody else gonna ask that, somebody else had a question real quick, why are they cold?
I think, if you have to keep them cold, like, how can you, like, use them?
Because once they reach ambient outside temperature, they are considered now, what? Okay, so their heat treating is now active, okay? So right now, while they're still cold, they can be bucked and formed. But once they reach ambient temperature, they are considered, all right, in their heat treated mode. They're resistant. If you were to try to manipulate them when they're hot, they are now beyond that operating temperature. So they're treated, okay, maybe they're treated, I don't know at what negative temperature it is, okay? And so they're not active until they reach ambient temperature. So the moment you buck them and they reach ambient temperature, I think it's like a 2-hour window. Boom, they're done. Okay, they can't be redone again. All right, this is out of your book here. I thought it was out of your book here. Let's see. There we go. So we have plain rivets. We have dimple rivets. Okay, cute little dimples. We have dimples. You'll see these very, 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 very common rivet is a dimple rivet. Raised cross rivet. Some of you will find a raised cross, raised dot rivet, 2 raised dashes. If you're not sure what these mean, look at AC 4313, page 4-21. 4-21. This is a side view of what thou might find. Okay? This is way more amplified than these little tiny rivets that are like this. Okay? You're not really, it's not that obvious. And number one, this is a rivet that's like that big. Okay? So you're looking at something like that, and these dashes are very obvious, but when you're looking at them, sometimes it's very difficult to tell. Okay? If you're not sure about a rivet, should you just use it anyway?
What's the difference in marking between B and E? They look the same. Oh,
You figured it out?
they correspond to ones on top. Okay. Yeah.
Bueno? Okay. All right. Alloy A are soft, non-structural rivets. Soft, non-structural. Alloy AD are the most common. AN 470 are universal head rivets. AN 426 are flush head or countersunk head rivets. Diameter increases in 30 seconds. Everybody good with that? Any questions on that? And then the length increases in 1/16. Okay. All right, I need to give you a break. Go take a break. Come back. Come back at 10. 10. We'll go for another